In these notes, we are going to look at, given the following, find the domain and range of each. So now that we've looked at each of the pieces, we're going to look at a graph, not just a number line. We're going to look at our domain and our range. So the first thing you want to identify is this graph continuous or discrete? When I look at example number 1, this graph is going to be a continuous graph because it is connected by 2 points. And so we must write our answer as an inequality. So here we're going to be looking at the domain. When you look at the domain, they are the x values from left to right. So here at this point, my x value is going to be -1, -2, -3, -4. And I know because this is an open circle, I'm going to have a less than symbol. And here it's a closed circle at a +2. So I'm going to have a less than or equal to symbol. So when I write the domain, I'm going to have -4 first, because I'm looking at my graph from left to right, +2 last, all of the values in between here, I cannot list them, so they are going to be represented using x, and then I'm going to use my symbol for less than at -4 and less than or equal to at 2. So in words, this is all real numbers greater than -4, because I'm talking about x, all of the numbers greater than -4, and less than or equal to 2. So when you look at the domain, just understand that you can see the restrictions on your graph. You're looking at your x values from the left to the right. Where does my graph hit my x values? -4, +2. Now let's go ahead and go over the range. When you look at the range, you're looking at the y values. So when we look at the y values on a graph, we look from the bottom of our graph to the top. And that helps us to identify where the y values are. So here, this point, it should be right here. It's a little off. It's going to be hitting, let's see, -1, -2, 3, 4, 5. So this is a -6 on our graph. And it's a closed circle, so we know it's going to be a less than or equal to symbol, all the way up to the top, which is at -1 here. So -6 to -1. At -1, it's going to be a less than symbol because it's an open circle. So you go in order from bottom to top. From -6 to -1, I'm talking about the range. So range are my y values. Y goes in between. At -6, I have a closed circle, so that's going to be my less than or equal to symbol. At -1, I have an open circle, so that's going to be my less than symbol. And when I write this in words, I'm going to say all real numbers, I'm talking about greater than or equal to -6 and less than -1. So this is a piece where you have to really identify, where am I looking for domain? Left to right. Where am I looking for range? Bottom to top. And you're using these points to help you identify what values you're identifying for your domain and your range. So if you needed to, you can even go back and take a look. This point here is at -4, -1. Excuse me. This point here is at +2, -6. So you can make that connection of, oh hey, my x's, this is my boundary for my x's, from -4 to +2. This is my boundary for my y's, from -6 to -1. You have to make that connection for range. It's from the bottom to the top. Domain is from left to right. Okay, you can pause your video, take some notes. We are going to move on to example number 2. Example number 2, we have a V-looking graph. We're not concerned with the shape it's making. We're concerned to identify, are these discrete, distinct points, or is this continuous? Well, when I look at this, the points are connected, so this is a continuous graph. I'm going to identify the domain as the x values, and again, when I look at my x values on the domain, I am looking at my graph from the left side all the way to the right side, and I'm using my points to help me identify where is it that I'm looking on my graph. So the right side is going to be, this is 3, 4, 5, 6. So I know that my domain is going to begin at 2, and at 2 I have a closed circle, so that's my less than or equal to symbol. At 6 I have an open circle, so that's going to be my less than symbol. So for my x values, the domain is going to be from 2 less than or equal to x less than 6. And again, my values came from 2 to positive 6. X is all these values in between, and I'm using a less than or equal to symbol because my point is closed, and a less than symbol at 6 because my circle is open. Now in words, we would describe this as all real numbers greater than or equal to 2 and less than 6. So now we need to identify the range. When I identify the range, I'm going to look at the y values, and I'm going to look from the bottom to the top of my graph. So range are the y values, and I'm going to look at my graph and identify from the bottom of my graph, it begins at this point here, all the way to the top of my graph. So I need to come up with those values and identify if it's going to be an open or closed circle using my inequalities. So here, this y value is going to be a positive 1, and I know I'm going to have a less than or equal to symbol because it's closed, all the way up to 6. I'm going to see this and I say, oh, I have 2 circles. Which one do I use? Well, because we have a closed and an open circle, the closed circle overtakes the open. So here I'm going to have at 1 a less than or equal to, at 6 a less than or equal to. It is including that value. So when I write my range from bottom to top, 1 to 6 at the top, y values are my range in between. At 1 I had a closed circle, so it's a less than or equal to. At 6 I had a closed circle, so it's less than or equal to. And now to write this in words, it's going to be all real numbers, I'm going to abbreviate, greater than or equal to 1 and less than or equal to 6. And I just abbreviated so you can see that. But please remember, understand that when we are writing this in words, we're not using the same symbol that's listed here. I have to describe all the real numbers that are greater than or equal to 1 and less than or equal to 6. All the real numbers that are greater than or equal to 2 and less than 6. So understand how to read that and write that in words using all real numbers. Okay, you can pause your video, take some notes. I'm going to move on to number 3. In number 3, we have a graph with points. These are distinct points. So when I go to identify, is this discrete or continuous? Continuous is connected lines. So no, this is discrete. It is not continuous. It is distinct points. So make a note to yourself. Distinct points. So when we have distinct points, we just list our values for our domain. If it's easier, you can take each individual point and write what each point is. So here at this point, it's at -1, 4. And I can list them off to the right if this is difficult to see. -1, 4. Here, I'm going to have a point at +1, -2. So +1, -2. Then I have this point here at 2, 4. So 2, 4. Next point is at 3, 2. 3, 2. I'm going to write it off to the side in case you cannot see it. And 5, 3. 5, 3. So I already have my ordered pairs listed. I just need to understand X values and Y values. I'm going to write the domain and the range in order from least to greatest. So here my domain, I will list my values in order from least to greatest. -1, 1, 2, 3, and 5. So I listed them in order from least to greatest, from left to right. In words, we don't have to write it in words when it is a discrete domain. When we want to write the range as a discrete range, we want to just list the range in order from least to greatest. So looking at my points, always remember range is the Y values. I'm going to be looking at my Y values in order from least to greatest. So when I look at my points, they're not in order, but I can look at my graph and identify my points to be in order from least to greatest from bottom to top. So here, my Y values at -2, that will go first. Then I'm going to go to +2, that's next. Then I'm going to write a +3 because that's my next value. I didn't write it here. And then here, when I see 4 listed twice, I don't have to write the repeats. I just have to write it one time. So let's go down to the range. It's going to be -2, 2, 3, and 4. And it's okay that they don't match with the domain. I'm not listing my points to be an ordered pair. I'm listing my domain and range in order from least to greatest. And again, you don't need the words for that example. Okay, and our last example is going to be a graph with an arrow going on and on and on. So when I look at this graph, I have to identify this is not discrete. It is continuous because it is a connected line. There is an arrow at the end of my graph. So I need to understand I'm going to have one number, one value, one variable. So at this point, I have +1, 2. So I want to identify, okay, it's going to include all the numbers to the right of 1. Well, what kind of numbers are those to the right of 1? Are they greater than? Are they less than? Well, all of the numbers are going to be represented by X for the domain. When I'm looking at the domain, at +1, I have a closed circle, and I'm including all of the numbers to the right of +1. Well, all the numbers to the right of +1 are greater than or equal to. So when I write my domain, I'm going to say X is greater than or equal to 1. 1 point, 1 number, and it goes on and on and on. Same thing with the range. So here we're going to say all real numbers greater than or equal to 1. Excuse me, sorry. Now we're going to look at the range. Range are my Y values. Well, here my Y values are starting at +2 and they're going down. So all of these numbers, because the arrow is going down, all of these numbers below 2 are less than 2. So when I write my range, I'm going to say Y, and again, it's a closed circle, so it's going to be less than or equal to, less than or equal to 2. So notice the symbols are different because Y values as you go down the graph are negative and they're less than. X values as you go to the right of your graph, they're positive, they're greater than. So here we're going to say all real numbers greater than or equal to 2. If you need to pause this video and go back and look at all of your examples, that would be a great idea, and take great notes when you do that.